All right, today we're going to work on solving, or actually, I'm sorry, graphing absolute value functions. We've already solved absolute value functions before, or absolute value equations. We're going to work on the graphs of these today and look at some transformations of these graphs. Okay, an absolute value equation is kind of a piecewise defined function. Okay, that's why we're talking about it right now. The complete absolute value function, if you want the whole thing, looks like this: f of x equals a times the absolute value of x minus h plus k. A, H, and K are numbers. Sometimes they're there, sometimes they're not. We're going to get more into this tomorrow, but that's what it looks like when it's fully written out. Like I said, A, H, and K are constants, which are numbers, and the f of x function has got to be greater than or equal to 0 for all values of x. The absolute value graphs are always V-shaped, so they're V-shaped, either a V, normally, or it could be upside down, depending upon a couple of different factors up here. All right, the vertex of the graph, which is the highest or the lowest point, is always at HK, the coordinates of HK. And the parent function. Now, parent function means if it's stripped down to just this very basic beginning, like f of x equals absolute value of x, what does that graph look like? That's the parent function. And then when I started adding all these pieces on here, it starts to change the parent function into some offshoots, some variations. Okay. What we're going to do is work on our graphs by making a table of values. I think it's the easiest way to see it, and we'll understand exactly what we have here. So what we're going to do is we're going to input values of x, calculate them in our function, find their outputs, and then graph them as ordered pairs. Okay, so let's start with -3. That means I'd have the absolute value of -3, which is 3, so -3, 3 is an ordered pair. -2 would be the absolute value of -2, which is 2, so -2, 2. -1, input that, it'd be the absolute value of -1, which is 1, so I got -1, 1. 0, right, would be 0, so I'm at 0, 0. 1 would be 1. 2, absolute value of 2 is 2. And then 3, absolute value of 3 is 3. So I just picked a few of these. Now, when we graph it, let's just graph the ordered pairs, see what we get. So -3, 3 is here. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. 3, 3. 4, 4. Go on forever. Okay. This is what it looks like. This is what we call the parent function. All absolute values stem from this original one. Okay. So that's what we kind of meant, like it was a piecewise. Like this line is everything from 0 to the left. This is the line of everything from 0 to the right. But it's actually just the absolute value function. Now we're going to graph these tonight, and I'm going to have you make table of values and turn the table of values in. All right, so let's look at this one. Graph the function f of x equals 2 times the absolute value of x. Okay. Well, again, let's make a table and let's input output. -3. So it's 2 times the absolute value of -3. We know the absolute value of -3 is 3 times 2 is 6. So -3, 6. Pretty simple, right? The absolute value of -2 is 2 times 2 is 4. So -2, 4. -1. 2 times the absolute value of -1 is 2, right? 0 will give me 0. 1 is 2 again. 2 is going to be 4. And 3 is going to be 6. Okay, so we make our graph. Lo and behold, we have our V shape again. But now the V shape, if you notice, is a little narrower, right? Before it was over 1 up 1, over 1 up 1, over 1 up 1. Now it's over 1 up 2, over 1 up 2, over 1 up 2, or up 2 over 1. So does that look familiar to you at all, this little slope here? So this 2 right here, because we multiplied all of our outputs by 2, it made our V shape skinnier. Okay. Now we don't have to know that because we're going to put a table of values together and graph it. But we knew it was going to be V-shaped. And now we understand that if we multiply it by a number here, it's going to make it skinnier. And it will get skinnier and skinnier if we multiply it by numbers that are bigger than 1. The graph, that is. Okay. -2x. What happens when I multiply by a negative number? Okay. Well, let's just go through the process. Okay. The absolute value of -3 is 3 times -2 is -6. So -3, -6. Absolute value of -2 is 2 times -2 is -4. Absolute value of -1 is 1 times -2 is -2, right? Keep going here. Absolute value of 1 is 1 times -2, -2. And you can see, how this is going to work out. So now if I plot these points and make my graph, it's upside down, right? So what happens is when we multiply the absolute value by a negative number, it gets flipped over the x-axis, okay? So now instead of going up, it's going down. And because we multiply by 2, it's skinnier than it would be. Normally it'd be over 1, up 1, over 1, up 1, over 1, up 1. That's the parent function, right? This is over down 2 over 1, down 2 over 1, down 2 over 1, treating that like a slope. Okay, so that's what happens when you multiply by a negative. Okay, what happens if we add a number in here? Well, let's take a look. Let's just go through the process here. Oops, I want that second, but it's first now. Let's go ahead and do this here. Put -3 in there. So -3 plus 1 is -2. Absolute value of -2 is 2 times 2 is 4. So I got -3, 4 right there. -2 plus 1 is -1. Absolute value of -1 is 1 times 2 is 2. So -2, 2. -1 is 0 times 2 is 0. So -1, 0. When I put 0 in here, now 0 plus 1 is 1. Absolute value of 1 is 1 times 2 is 2. So there we go. 1 plus 1 is 2. Absolute value of 2 is 2 times 2 is 4. 3, absolute value of 3 is 3 times 2 is 6. And then the absolute value, actually, we got 3 plus 1 is 4. Absolute value is 4 times 2 is 8. So here's my graph, right? So what happened here? Okay, well, we multiplied by 2. So we didn't go over 1, up 1, over 1, up 1. We went over up 2 over 1, up 2 over 1. So that's the 2 factor, right? It made it a little skinnier. And then what happens is normally the parent function is here at 0, 0. Well, it slid over here. It's over here to -1. And what happens is this number right here is what does that. We take the opposite of this number, and that's how we move it left and right. So because that was +1, I moved it to the left one. Now we're going to get into this more tomorrow, but this is just for you to see. Okay. All right, let's do this one. Could make some predictions, right? We got a negative sign in front, which means our V shape's going to be going down. I'm not multiplying it by a number here, so it should be over 1, up 1, over 1, up 1, or down 1, over 1, down 1, over 1. And the -2 should slide it to the right 2 places. So we should have a pretty good idea how to graph it without even seeing the outputs of the table yet. But let's go ahead and do that. Well, actually, I boogered it up, so it's going to be over here first. And I was right. Okay, it's going down. And I didn't multiply it by anything, so it should be over 1, down 1, over 1, down 1, over 1, down 1. And we slid it over 2 because of the -2. We do the opposite, so we slid it to the right 2. Now let's match it up here. Input of -3. -3 minus 2 is -5. Absolute value of -5 is 5. The opposite of that is -5. So there's a lot of work there, right? -3, -5. So -3, -5. -2. -2 minus 2 is -4. Absolute value of -4 is 4. The opposite of 4 is -4. So I got -2, -4, -1. -1 minus 2 is -3. Absolute value is +3. Opposite of +3 is -3. 0, 0 minus 2 is -2. Absolute value -2 is 2. Opposite of that is -2. So 0, -2. Put in 1. 1 minus 2 is -1. Absolute value of -1 is 1. Opposite of that. Put in a 2. 2 minus 2 is 0. Opposite of 0 is still 0. So 2, 0. And then the 3, the last one we have, 3 minus 2 is 1. Absolute value of 1 is 1. Opposite of 1 is -1. There you have it. Okay. Now we could keep going over here and finding input outputs, but this gives us a pretty good idea of what our graph's going to look like. And you guys are going to make these tonight. Okay. Input output tables. So I want input output tables for all of our homework questions. Get used to graphing absolute value, understanding, what the graph's going to look like before you even make it. Okay. All right. I'll let you have at it.